I aquí què tenim? Doncs mireu, aquí tenim una ponència que s'emmarca en una de les corrents crítiques del pensament sobre dades i que anirà a càrrec de Geoffrey Bowker de la Universitat de Califòrnia. De fet, crítica de dades, això ens remunta a la ponència inaugural d'aquest Congrés. Bowker va participar en un llibre col·lectiu que es titula Raw Data és un oxímoron, editat per Lisa Gitelman. Jesús, salut. Aquesta obra i, per consegüent, els autors que van participar-hi s'emmarquen dins d'aquest estudi crític de les dades. Es tracta d'aquesta corrent que s'allunya de la idea que les dades són objectives de per si. Això ja ho vam comentar, la música us ha de sonar, ja que es tracta això de representacions i, per tant, hi ha un component subjectiu important. De fet, la tesi principal d'aquesta obra és la idea que les dades són en brut, d'aquí ve raw data. Les dades són en brut, per tant, és un oxímoron, és a dir, associar dades i brut és contradictori perquè les dades sempre són netes, sempre estan cuinades aquestes dades. I no podem pensar que les dades són tampoc un recurs natural, sinó que és un recurs cultural marcat per un context determinat. Mireu, jo us recordaré una època fosca passada, recent, el confinament, on estàvem tots absolutament pendents de les dades, d'aquell índex que sortia cada dia amunt i avall, i va haver molt de debat sobre... Estàvem absolutament sotmesos a les dades. Si pujaven ens tancaven, si baixaven ens deixaven treure una mica la poteta fora, si no... I ens deien que aquelles dades eren objectives. Mentida. Aquelles dades eren absolutament cuinades. És a dir, ens arribaven les dades que convenien en cada moment. D'aquí ve, és una de les arrels d'aquesta corrent crítica que ara sentirem aquí. Qui és Geoffrey Bowker? Doncs és president emèrit de Donald Brent de l'Escola d'Informació i Ciències de la Computació de la Universitat Califòrnia a Irvine i actualment treballa sobre temps i computació sota la rúbrica Vida al femtosegon. Rebem amb un fort aplaudiment a Geoffrey Bowker. Endavant.
Right, well, thank you for the kind introduction, and it's a great pleasure to be here. Although I trained and worked as an archivist, I very rarely have gotten to attend archivist conferences, and I've learned so much here already that it's been a total pleasure to be here. For example, just in the last panel, Dara Hoffman bringing out the centrality of records keeping skills, I think, and recognizing the continuity between the past and the present is really very important. We often think that the digital, well, it's all new, and it's really not all new. There are problems, there are issues that go back many centuries, as I'll touch on slightly today. I want to start with the fact that there is so much information, so much data coming out in the world today. Every minute of every day, there are 1 million texts, there are 347,000 tweets. Well, that's actually an old figure. That was pre-Elon Musk days. I suspect it's a lot less now. And there are 500 hours of YouTube produced, again, every hour of every day. It's too expensive to capture it all. We think that we dream of a perfect archive, but the Library of Congress in the US, for example, has stopped even trying to document all of Twitter. There's just far, far too much of it. Today I'm going to talk a fair amount about scientific archives. There's a couple of reasons for that. I mean, partly because it's my area of expertise, partly because the natural sciences do claim a perfect memory, and I want to question the fact that they have a perfect memory. And they seem to be the hard case. So this is Descartes Labs, the power to model the world, actionable intelligence powered by geospatial data, backed by science and available at planetary scale. This reminds me of, Devin Mordell's lovely talk yesterday about the refinery model and the problems of the refinery model with respect to data. There are dreams of universality. There are dreams of being able to take it all in and use it all. But I will try to show that they're all dreams. In fact, I'll be talking much more about difficulties than I will about possibilities. This is not to be negative, but it's just that I think we need socially and organizationally to confront the difficulties of extracting information, as well as the difficulties, as well as the beautiful affordances of being able to analyze it. So the talk will be in 3 parts. I'm going to talk about classifying and the work of classification first. Then I'll talk about data, metadata, and then about the work of metadata. Now, we often don't think of classifying as being a political act, but here's a recent example which I just loved. Bumblebees can be classified as fish under California conservation law, the court says. In a move that could allow a broad range of insects to be considered for endangered species status, the state Supreme Court has found that California bumblebees can be protected under law as a type of fish. This is actually a common kind of classification problem that we face. I was working years ago with folks at the library of the University of Illinois at Urbana-Champaign, and we had to take the library books down from the library contents down from 32 to 18 what were called material types. So law journals were not classified as journals anymore. They were classified as reference books because they acted like reference books, just in the same way that bumblebees are classified as fish because they want to act like fish. Typically of the 1980s, this is a kind of fairly bog standard example of market segmentation used in marketing. Right now, that's not in a sense the way that marketing works. Nick Seaver, for example, has written beautifully about music recommender theses, music recommender systems, and how they don't deal with you like rock, you like folk, etc., etc. They deal with what kinds of chord progression do you like, what kinds of notes do you like to go together, and that's where you get a nice mix of genres when you log on to their programs. But as Kate Crawford argues in her marvelous Atlas of AI, classification is still at the root of a lot of artificial intelligence work. Let's look at 1 or 2 examples of the difficulties of data. This is a fairly standard example. A beauty contest was judged by AI, and the robots didn't like dark skin. It's often been found a prejudice against dark skin, against black people in AI systems being developed largely by white men in the United States. It's extremely difficult to regulate these algorithms, automatic algorithms, in such a way that they don't include the political. Here's one of my favorite examples from a few years ago. This is LaTanya Sweeney, who runs the Data Privacy Lab at Harvard University. And she ran a series of searches, Google searches, which triggered ads by Google on the right-hand side of the screen there. And so when she typed in typically white names, then she got the ads by Google were, something like went to school here, this is the kind of thing they do, this is their occupation, and so on and so forth. When she typed in black names, she often got Ebony Bookman, The Truth. Looking for Ebony Bookman, check Ebony Bookman's arrests. So arrests came up first. as a way of categorizing black people on the web. This is a kind of problem that's discussed very well by Sophia Noble in her book, Algorithms of Oppression. The problem here is, every time you point out a problem like this at Google and other search engines, they fix it. But the problems are systemic. They keep coming back in a different form. And so until we recognize the inherently political nature of what's going on, we won't solve or deal with the overall issues. It's a study that Anya Beckman did a few years ago. I co-wrote an article with her on this. And this is about a study of Facebook and facial recognition in Facebook, which again you think is going to be, it's going to be fairly objective and fairly reasonable. The facial recognition program from Facebook did not recognize the face on the left there as belonging to a man, because men aren't supposed to be holding babies, so they just rejected that they just rejected that data piece out of hand. Similarly, they didn't recognize beer-swilling women, because women are supposed to act more decorously in public, and so again, these were tossed out of the data sample. So even though you think it's going to be automatic, you think it's going to work, it's very, very difficult to really do that. I recommend for your attention here Florian Joton's superb book, The Constitution of Algorithms, which is an ethnographic study of facial algorithms, facial recognition. We really, really do need more ethnography. We really, really do need more close studies of what's going on behind the scenes as this kind of algorithmic work is being done on data. So out of the study, we came up with a few examples of where issues might arise with the data. I'll just talk briefly about a couple of them, concentrating on the right-hand side there of the table. One is data samples. Data samples are a huge problem, and it's not obvious. Many studies in the field of computer-supported cooperative work, one of my cognate fields, dealt with Twitter and the Twitterverse. And there's a real problem with the Twitterverse. I mean, in a sense, you think, there's so many megabits of data, so many terabits, actually, of data coming out all the time, that somehow we get a reasonable account of the population. We really don't. There are a very, very restricted number of people who use Twitter, very restricted by social class, by access to computing. And so even though we have so much, an overwhelming amount of data, it's very, very difficult to work on. Second problem I want to highlight here is the fourth one down in there, data preparation. Standardizing data takes a huge amount of work. For example, the Harvard project on historical spatial data, the China Historical GIS project, has a real problem with working out what are actual geographical units within China historically. This is much the same problem, by the way, with temporal units in historical databases. That reconciling of all these different geographical units, which we'll come to in a second in another sense, is actually really, really difficult. I won't go into the model thing. Okay, so science, and I'm going to use a couple of scientific examples now of classification. You can see the sort of range here of difficulties. The number of species, according to one article in Science, says that we have 1.5 million species, but we know that there are vastly more. We've named 1.5 million. The highly educated guesses of late have ranged from 2 million to 1 trillion. Most are in the range of 11 million or fewer. So you see between 2 million and 1 trillion, we really, really don't know much about species and species on Earth, even though huge amounts of work have gone into building the scientific archive around them. There's yeah, well, you can see the three cases there. Animals in 1992 make up 72% of the natural world, 90% in 2011, and only 7.3% in a study that actually pays attention to bacteria. So even though you might think that we know a lot about species, about life, and that we've catalogued some, and we've got such a fantastic scientific archive, in fact, it's always already problematic. And we often think of life in terms of the tree of life classification, where things branch off, so you get everywhere, and you can't quite see there, I suspect, on the screen, but you get Darwin at the very top as the nec plus ultra of evolution. But I want to draw attention specifically there to one of the ways in which the tree of life is broken down. Viruses and retroviruses really, really don't fit in. Are they examples of backward evolution or forward evolution? And when they do the databases of, when they try and work out species history, they have a huge amount of difficulty because of the power of the computers isn't big enough. So they use algorithms which assume that evolution always goes in the forward direction, whereas they know that there are cases of backwards evolution, and viruses are one possible case of that. So fungi for a second. Is it fungi next? Yeah, fungi. The best estimate suggests that there are between 2.2 and 3.8 million species of fungi in the world, 6 times the estimated number of plant species, and merely 6% have been analysed, been described. Or again, there are almost 1.5 million fungal species on Earth. This is 2 texts at the same time. Both were respectable scientists. They perform essential ecological roles, etc., etc. Now, one of the problems here, and this is a problem I've come across a lot in dealing with scientific data and archives in science, is that concepts which are central to some disciplines are not so central to others. For example, as Coyne and Orr point out, there are lots of concepts of species, and all of them work better for mammals than fungi. And so what many scientists are trying to do is fit fungi into the model of species, because species are what we know. They're what we know how to count. They're what we know how to archive. They're what we know how to archive. But species can be problematic for entities like fungus. And indeed, Nicholas Money argues against the naming of fungi, saying that rather than stretching the species concept to accommodate just about any set of characters that seem to separate one organism from another, perhaps we should, pending further science, abandon the notion of fungal species. The desire to tag everything with a binomial has become so deeply embedded that it may seem preposterous to suggest that mycologists stop doing it. But if the basis for attaching a Latin name to a fungus, and the Latin name comes from Linnaeus, Linnaean binomial names, absolutely central to most scientific databases biologically. We talk about 1 million or more species as a badge of honor, but we really don't have a clue about the real number, which I think is more true. I had another example there. Let's go back to this one then. So a problem with money there is that, the problem of being not central to a particular area, that occurs very, very frequently, in fact, and the same issue occurred in a study I did of GEON, which was attempting to bring together data from all of the geological sciences. Basically, seismologists run the show because seismology uses AI most, uses the latest computing most, is the most amenable to computing, whereas areas like like environmental hydrology, do very badly. Okay. Yeah, just going to. Yes, and the other thing is, considering species and the problematic with species, we would have a completely different reading of the world if we looked at symbiosis as the collect unit rather than the separate species. We also would have a completely different understanding of our own bodies if we looked at the metagenome. 90% of the cells in your body are not actually your genetic code at all. They're all flora and fauna that exists in your stomach and scattered throughout your body. But we typically think of the body with respect to human body with respect to genetic code because it's amenable to analysis, it's amenable to computing, and it provides a sense of certainty. And there's a huge problem as well with classification, and what's the work that's being done on the ground there? This is the Munsell color chart, which is used in the classification of soil. Charles Goodwin wrote about this beautifully in his article called Professional Vision. First of all, it's very difficult to classify soil. Secondly, you need to train scientists to distinguish between all those different colors, because people have slightly different visions. Some are colorblind in some ways, some are colorblind in others. So actually, what seems to be a simple objective measure, which you then want to transfer across to the computer and gather automatically, is actually very, very difficult to achieve. With the additional problem that it matters when you take the sample. If the sample is taken on the spot and analyzed on the spot, it's often wetter and darker than when it appears in the laboratory later. So, final bit on classification and the issues of classification. Many of you will know that the census is always and has always been highly political. In fact, in France, the census questions were largely based on Pierre Bourdieu's somewhat problematic but very interesting theory of social class. The citizenship question that Trump was trying to push several years ago was obviously politically problematic, scaring people away from the census, which has political consequences. It means that underrepresented communities will remain underrepresented. One of the more interesting things there, facts lately about the census, is that within America you can now belong to multiple ethnic categories, where before you had to choose just the one, which was a vestige of the old eugenics and a vestige of the old racial theories, which have been thoroughly disproven. But it made a difference, and that's the other point that I was making earlier about classification. It really, really makes a difference because public funds tend to go to people. Public funds go to counts of people which are based on categories in the census system. So in one sense, what you want is a strategic essentialist account, which says, okay, there's only, I am only black, or I am only, I am only Latino or Latina. And in another sense, in terms of accuracy and in terms of what's more interesting scientifically, you want many, many different classifications, ethnic classifications, to be working at the same time. Okay. So onto the problem of metadata. I'm running a little low on time, so I'm going to dump the Earth will don an electronic skin. That was an article by, what's his name? Neil Gross in 1999 that really gave rise to the concept of the Internet of Things. And the current vision of it, which is receiving huge funding, and I suspect many of you know this much better than I do, is the concept of the digital twin. And the digital twin says, okay, what we're going to do is we're going to recreate the entity, in this case, an aeroplane, model its data, model how it works, and then we're going to do the computing on it, and we're going to spit out some results which will be accurate for the real world. Massively problematic. Steve Barley did a lovely study of trying to create a digital twin of a car so they didn't have to do car crash tests. And they ended up having to go back to analog models because the digital twin didn't work well enough. So metadata really, this is where, it's actually from LaTonya Sweeney, but it's where information about you, the patient, goes in all the different entities in the United States which deal with it, the researchers, the personal transportation, life insurance companies, health IT, media, analytics, pharmaceutical companies, vital stats, and so on and so forth. Now, the problem with that is that each of those different entities has somewhat different metadata needs. And in fact, the need for metadata can end up being somewhat infinite. For example, accident classification and the international classification of diseases really doesn't work because there are so many kinds of accidents that occur. The international classification of diseases, which is used for collecting data about causes of death worldwide, is incredibly unhelpful on environmental data. It's very good on punctual data. It's very good at what medicine is very good at doing, and it's very bad at what medicine is very bad at doing. And a good example of why digital twins go wrong is the wonderful work of Antonia Walford about the Amazon. You'd think you're just getting pure data here. This is from the canopy in the rainforest in Brazil. Notice there were some Spanish researchers there as well as Brazilian. And it was streaming data. And you think, well, streaming data, there will be no problem whatsoever. We don't need classification. We don't need, we don't need any political interpretations I've been trying to give. It's just streaming data. Actually, it's highly problematic. She writes, she describes the twin idea in terms of second nature and trying to create a second nature inside the computer. Now, the problem with this is that the database classes used within the computing network they're creating are always already theoretical. For example, when wind speed comes out from a streaming sensor as being too much theoretically to occur, then it's assumed that the sensor is wrong rather than that the theory of the range of possible wind speeds is wrong. And she gives many, many other examples like this. You're already massaging the streaming data in the process of creating the databases which are going to store it and archive it. And I'll prefigure to an issue I'm going to come up against in a few minutes, the issue of control of the database. The database owners in Brazil actually made decisions about who they would share the data with based on whether they believed that the data would actually be useful for their scientific projects or not. So there's a second level of management of the data that's going on there, which is often quite hidden. And I'll come to that in a second. Now the metadata problem. This is James Enote, who's a Hopi, who's done some wonderful work on Hopi artifacts for a number of years. And he worked with Ramesh Srinivasan at UCLA on Hopi artifacts in different museums spread all over the United States. It's very, very difficult to compare artifacts here because different museums have different naming conventions. And it's very, very expensive to go from museum to museum and reconcile all the different names that occur. So even though you've got, what can be some pretty amazing and apparently complete collection of artifacts, you've got it's very, very difficult to do analysis of it. Yeah, I've got time for this very quickly. And here's one of my favorite examples of this. This is records of fossils, so archives of fossils in Europe. The Austro-Hungarian and British empires can be traced through fossil collections in Vienna and London, respectively. This led to different sets of synonyms because London and Vienna had different names for fossils, and thus to different apparent biogeographic reasons. So the political empire gets writ large on the natural world. There's also a difficulty that scientists tend to say, well, I work on the Cretaceous, you work on the Tertiary. So even though, and very, very few people work on both together, what that means is that you often get discontinuities in the historical record between the Cretaceous and the Tertiary, basically because you've got Cretaceous scientists on the one side of the divide and Tertiary scientists on the other who have different naming conventions. Same issue occurs with hospitals, for example. Hospital causes of death. Cancer is much, much more popular as a diagnosis in the United States than it is in Japan. Heart attack is much more popular as a diagnosis in the United States than in Japan. So that's metadata. Let's spend a little bit of time on the work of metadata and the difficulties of the work of metadata. This is one of my favorite examples. It's the Protein Data Bank, largely created by Phil Bourne, UCSD, later moved to Washington. And it looks, Protein Data Bank is an amazing, it's an amazing database containing all the protein structures that are known. New protein structures are being added every day. And it's often forgotten that there are middle people in this process, and we often forget the middle people in the data gathering process here. That basically what happens is a working scientist, a microbiologist, has to, in order to get their work published, they have to provide the structure to the protein data bank, which then becomes the archive of all proteins. Now, the difficulty of that is that over 90% of the records produced by the scientists themselves are wrong, and they have to be changed by hand by a group of annotators working in Washington. And it's those forgotten middle people who are, I think, really, really important. The same issue occurs, by the way, with hospital records and records of causes of death. And for the International Classification of Diseases, it's reckoned that over 70% of causes of death given by doctors are actually wrong. There's a good reason for that. Yeah, I've got a second. There's a good reason for that, actually, which is that doctors are very, very busy people, so they don't want to spend the time leafing through a huge, long document working out what's a precise cause of death. They'll tend to go for the more general cause of death, whereas what's interesting epidemiologically is the more precise form of death, and that's why that second layer of invisible work needs to be done in order to make it work. Again, a case of the forgotten middle of data. And again, a case of the different uses. Epidemiologists have different uses for the data than doctors do. Doctors don't really care once someone's dead, and that's where the work starts for the epidemiologist. Yeah, I won't go into this in detail. Yeah, it's just more on the protein data bank and issues with the protein data bank. No, I'm not going to do that in more detail. So here's a case, a kind of government case, which I found really interesting. This is Antoine Cormont's work in recent years on Lyon as the winner of the gold medal of intelligent French cities. And they spent millions and millions of dollars on creating a digital city. That was the big thing about, it has been a big thing over the last 20 years. This is 2013, this example. And again, it seems as if it's a relatively easy problem. What we've got is all of these different databases. We've got databases of road transport, we've got databases of public transport, we've got databases of transportation, we've got databases of maps of city parks, we've got maps, so maps on maps on maps. Now, actually getting those maps to work together proved to be impossible for the city of Lyon. After they'd spent about 8 or 9 years on the project, they just gave up and used Google Maps instead. The reason for this was that the core issue, well, two core issues. One is that the maps, it was very, very difficult to reconcile the maps. Road transportation and public transportation didn't reconcile. They used slightly different renderings of the city of Lyon. So that was one reason. That reconciliation work, again, has to be invisible work, which is done in the middle. The second core issue is that technical claims often hide political claims. So one agency of the government would say, well, using data from, say, the public transport authorities is impossible. And they'd claim that it was technically impossible, where in fact it was often a political issue, which is, I don't want to work with those people, I don't like them, and I don't want to see my work getting merged with theirs in some kind of way which is threatening to me. So what is often claimed as a technical issue becomes a political one. Then you get these wild dreams of the work of metadata. I actually do love this company, PIQL, which is it's archiving now UNESCO cultural objects, I think. But the idea is it's for anyone all over the world. Keep your information alive, secure, and accessible for the future. We will transform your. PIQL can help you transform temporary to eternal with guaranteed access. And you think about the work of metadata, well, this is impossible anyway. First of all, PIQL, their databases are held in the Svalbard in Norway, next to the seed vault there, which was chosen as a site largely because it was in permafrost, but with climate warming, it's now liable to flooding. So it's difficult already. But the second issue is, how does PIQL envision the eternal in this? What they need to keep, what they need metadata on is, first of all, how to build a machine that's going to read the data. Secondly, the operating system and the version of the operating system that will support the software. Thirdly, they need metadata on the software and all of the different iterations of the software that they're going to run to make it work. And fourthly, they need to encode all the data. And they've recognized all this, but you can see again that what seems to be, for PIQL, a seamless process actually involves a huge amount of metadata collection. And even when you do the metadata collection right, you miss out things quite often. This is an example of a project I was working on for a few years with the Yolngu. They're a largest Aboriginal group in Northern Australia. That's the area in grey there, is where they live. We were trying to create a database of Indigenous knowledge there, which, you know, sounds nice. I mean, let's find out what they know and let's put it in. Two problems there. No, I don't have time for the first problem. So the second problem, this is from the Teaching from Country project by Michael Christie, is that at the end of the day, the Yolngu said, we do not want a digital representation of our culture and who we are. As one of the elders said, land connects everything, the culture, the songs, the dance, the stories, everything, art, painting. So what they wanted instead of some kind of digitization of their records was they wanted us to create mesh networks out throughout Yolngu country so that stories could be told from within the country and based in the land. You could not tell that story from outside of the land. So even when you've done the metadata work, you often miss quite a lot. So, yeah, I mean, this is David Lair and Paul Ohm. Paul Ohm's one of the great thinkers in this area. And again, he points out the work. Machine learning algorithms are the complicated outputs of intense human labor from data scientists, statisticians, analysts, and computer programmers. From the moment these humans conceive a predictive task to the moment the running model is deployed, they exert significant influence over everything from how the data are cleaned to how simple or complex the algorithm's learning process is. Along the way, they have the power to affect the model's accuracy, explainability, and discrimination. I don't really have time for that. Yeah, well, I did want to point to this. So again, this is a work of metadata. This is an insurance company represented in the 19th century. You'll see that a fair number of the workers there doing the metadata work for producing, what are they called? I've forgotten the name. Yeah, for producing risk factors, lists of risk factors for citizens. Largely mixed male and female in the 19th century becomes undervalued work in the 20th century. Largely, actually, I think every example in that, every person in that slide is a woman. So, what I've been trying to say in this is that we often think infrastructure is simple and that we can create the perfect record, the perfect archive, but infrastructure is always messy. It always involves humans. It always involves a lot of work, and it's frequently highly political work. So to conclude, a few things. This is Scott Mutter's wonderful serrational image, Michigan Street in Chicago. And I think it's really important to understand that underlying every city, underlying every urban agglomeration or whatever, is a catalogued, a ways of cataloging people, ways of cataloging entities, ways of storing data. So data work is actually pretty central to the running of our cities, the running of our societies, and it's based on classifications, and it's based on hidden and invisible work. One of the great examples here, for me, is from Johanna Drucker, there's an ironic remark by Willem Flusser that it's been clear for several centuries now that it's not sufficient to describe it by words, it's necessary to calculate the world, which is often the way in which people creating the archives today are thinking about it. Johanna, quite rightly, I think, points out that data, that which is given, shouldn't really be the term for it. It's really capta. It's that which we choose to capture. And that which we choose to capture is, in itself, a really interesting choice. So, if data is central to our society, this is Meletti, an Italian architect, producing the idea for a 65-story data tower in Iceland. You sort of want it in Iceland because you've got geothermal energy and you've got the cold air. But what he says is large libraries of the past were built with majestic designs. As data centers become repositories of all our culture and knowledge, we must not ignore them. And so he wants to create this spectacular architecture for data centers, which I actually fully agree with. But if you look at data centers today, they're hidden away. You often don't know where they are, and they're extremely difficult to get access to and extremely difficult to map. So there's an essential tension here that you want numbers. You want to be able to count things, you want to be able to put things into boxes, and you want to be able to work it. But as Neer and Kirk point out in a completely different contexts, peremptory quantification risks begging all the big questions. So recognizing that tension rather than trying to fight it or assume we've got past it is, I think, really important. So the data double, the data twin, a few points about this. First, the figure on the left, figures on the left, data. when you try and create a digital twin of a person, which really, really affects how that person is in the world and how they act in the world, you need to recognize that it's not an accurate representation. And secondly, this is Joanna Ricou's lovely self-portrait, which recognizes that as much as counting people in genetic code, we should be counting and looking at the microbiome, all of the flora and fauna. So finally, representation inspired by Snowden. Archives and archival work are key sites of political work in the world today, and I think that's why we need the social analysis of archives to go alongside of, not to put down, not to denigrate, but to go alongside of the very real work of producing all the wonderful applications and all the wonderful possibilities that we've seen yesterday and today and in the world in general. But we need to recognize that a lot of work goes into metadata. Metadata is difficult. Classification is difficult. It's always already political. So recognizing that in a systematic way is, I think, the way forward. Thank you.
Gràcies. Geoffrey C. Bowker ens ha explicat moltes coses, moltes coses, molts conceptes. Sí que jo m'he quedat al començament, ha dit, regular els algoritmes és molt difícil. Jo crec que aquí, quan parlàvem de que les dades, al darrere sempre hi ha decisions polítiques, i crec que al principi, quan parlàvem de que en aquest congrés s'havia fet un esforç perquè fos paritari, però que en el sector on estem, en el sector STEAM, costa molt que hi hagi dones, i jo feia aquella referència, escolteu, quan es fan els algoritmes, si les dones no hi són, passen coses. I avui, a la seva explicació, Geoffrey C. Bowker ens ho ha posat de manera diàfana, quan ens deia, clar, qui fan aquests algoritmes? Homes blancs, i què ens n'hem adonat? Doncs escolta'm, que són racistes, que no els agrada la pell negra. Ens ha posat un exemple molt clar. Ens ha posat un altre exemple sobre els estereotips de gènere que tenim entre homes i dones. Com pot ser que el reconeixement facial del Facebook no reconegui un home amb un nadó, un pare amb un nadó, o unes dones bevent cervesa? Escolta'm, jo bec cervesa, com pot ser que no? Totes aquestes coses que fa tants anys que ens cauen a sobre, tornen a caure sobre aquests algoritmes que haurien d'estar lliures de tot això, però estem fabricant un món que repeteix tots aquests clixés. Per tant, això no ens ho podem permetre. I ell ha parlat de problema sistèmic, un problema sistèmic que ens ha de preocupar. Ja no és una cosa que passa, sinó que és una cosa que ens ha de preocupar i que ho tenim aquí. Jo crec que ho he entès més o menys tot, però Déu-n'hi-do. Ha parlat de la classificació de les dades, ha parlat també de les metadades, ens ha quedat clar que els bessons digitals no funcionen, que no, i ens ha tornat a parlar una altra vegada dintre d'aquestes metadades, d'aquesta dificultat de classificar, i hem vist clarament que sempre hi ha aquesta decisió política subjectiva que fa que el resultat canviï. I ens ha parlat d'aquesta capa invisible, diu, sempre hi ha aquesta segona capa invisible de classificació, que és importantíssima, i ens ha posat dos exemples que a mi m'ha deixat al·lucinada. Quan parlava de les proteïnes, aquella foto tan bonica que hem vist de l'arxiu de proteïnes, deia el 80% està malament. Aquesta segona capa de gent han hagut d'estar treballant molt perquè això funcioni a nivell de metadades. I també ens ha dit el 70% de les causes de defunció també estan malament, perquè els metges van de pressa, apunten les de sempre i ens perdem, aquestes capes invisibles. I llavors ens ha dit, hi ha molts problemes que ens diuen que són tècnics, i en realitat no són problemes tècnics, són problemes polítics, i ho hem vist molt clar. I a mi m'ha agradat aquella fotografia, que a ell també li agradava molt, que veiem una ciutat i a sota veiem les dades, deies que la representació de la ciutat, de la humanitat, són aquestes dades que són essencials per a la nostra societat, però no es veuen. I m'ha cridat l'atenció una cosa, quan hem vist aquella biblioteca futurista a Finlàndia, crec que era, que dius, ostres, abans les biblioteques, i és veritat, pensem en la biblioteca d'Alexandria, eren llocs on s'exhibien aquestes dades que teníem, aquests llibres en paper, eren llocs bonics, preciosos. I ara els amaguem, no?, a sota terra, no les veiem. Ens hem de replantejar potser com han de ser aquests llocs on s'emmagatzemen aquestes dades que en el fons són l'essència, la cultura de la nostra civilització. Jo demano un altre aplaudiment per aquest home que ens ha explicat coses molt interessants. Vinga, som-hi, que estem a punt d'anar a dinar. I jo no sé si algú de vosaltres té alguna pregunta. Pugeu una mica al llum de sala, companys, perquè us vegi. A algú li ha quedat alguna pregunta, alguna reflexió que vulgueu fer al nostre convidat? Sí, no? Vaig veient. Això vol dir que s'ha explicat molt bé. Per tant, escolta'm, jo el que faig ara és emplaçar-vos...
No, I think it means that lunch is coming.
Que tenen ganes d'anar a dinar. Hem de dinar. No, ho hem de fer tot. Jo crec que podem compaginar les dues coses, que ganes d'anar a dinar i que s'ha explicat molt bé. Geoffrey C. Bowker, thank you very much. Un altre aplaudiment ben fort per ell. Moltes gràcies. I ara sí que us dono les indicacions. El dinar, escolteu, és el lloc de sempre. Deixeu-me que us digui unes quantes coses que us convé saber, que aquesta tarda totes les activitats es concentren a l'auditori, per tant, els que sou aquí ja us ho dic, ja ho sabeu. Tenim taula rodona i dues ponències al voltant de la intel·ligència artificial, que és un tema que aquests dies, no sé si escolteu mitjans de comunicació, però està el tema cada dia a les primeres notícies. I s'ha acabat el desdoblament a la tarda. I recordo també, important, recollir el tiquet del sopar, que aquest vespre tenim sopar de gala, on m'ha dit que us desmadreu una mica, ja després ja us donaré algunes indicacions. I quan acabi també aquesta jornada d'avui hi haurà assemblea de l'AAC en aquest mateix auditori, per tant, els que us quedeu a l'assemblea també us donarem indicacions. Samarretes, xulíssimes, en tenim 3 a la venda allà a l'estant, 10 euros pels socis, 15 pels no socis, si les voleu a 10 us feu socis i sòcies i cap problema. I dir-vos que teniu per dinar 1 hora i mitja i que a 3:15, 3:30 us vull a tots i a totes en aquest auditori. Vinga, som-hi a dinar, bon profit i moltes gràcies.